Looking underneath the first 6 problems, what patterns did you notice in A through C? So in part A, we got x squared plus 2x minus 2x minus 4, and the middle two cancel, and I get x squared minus 4. So in A through C, even into D, the middle terms always canceled. Why is that the case? They're the same factors, but they have different signs. So in A through D, we have the exact same factors. The only difference is the signs change from one side to the other. What do we call it when we have factors that are exactly the same with a different sign in the middle? That's what the quadratic is called, but the factors are called conjugates. So together they're called conjugates. If I told you x minus 4 and I asked for its conjugate, it would be x plus 4. It would be exactly the same, we just changed the sign. So the third question, what do we call this type of quadratic? Difference of squares. Now, a couple neat things happen here. The only factors that have terms that cancel. So if you multiply two factors together and the middle two terms canceled, that guarantees that you have conjugates. Okay, the other thing is, if you have a difference of squares, that can only be created using conjugates. Now, having said that, we look at part E. Did the middle term cancel in part E? Yes. Do we have conjugates? No. So if we look closely at E, we do in fact have conjugates. But what do you notice about that first factor? Nice dance. Can you do that again? Oh. And you even had a soundtrack. Did anybody else witness that? Okay. What do you notice about that first factor? Okay. Can I factor anything out of that? A 2. And if I pull out a 2, I get 2 times 3x minus 11, which is a conjugate to 3x plus 11. Whoa. That's a Chasely parenthesis, the one that's got the moves. I think in honor of Chasely, we'll use those for the rest of the day. What about letter F? And that's supposed to be a plus. I can take a 3 and an x. Oh, sorry. And then I'm left with 2x plus 15, and then 2x, 5. And then 2x minus 5. My nifty parentheses don't have a soundtrack, though. So the last question asks, why did the middle term cancel in problems E and F? We did have conjugates. They were just hidden within one of the factors. Hidden conjugates. That's the secret. So we're going to work some problems similar to your assignment. Part G, factor each of the polynomials below. So looking at part G, do we have a difference of squares? Yeah, we have, looking at the first term, x and x. Looking at the last term, 1 and 1. And we know that they're conjugates, so that the signs are different. But you need to remember, this only works for difference of squares. What if I tried to do the sum of squares? It's not possible. How come? Right. My choices are x plus 1 and x plus 1, or x minus 1 and x minus 1. And in both cases, will my middle term cancel? No. So this one turns out to be x squared plus 2x plus 1, and this one is x squared minus 2x plus 1. So the sum of squares never works. In fact, the sum of squares always has imaginary roots. Because if we think about x squared plus 1 equals 0, what do I need here in order to add 1 and get a 0? A negative 1. Can I square a number and get a negative 1? Well, 1 times 1 is 1. That didn't work. Negative 1 times negative 1 is 1. That didn't work. So this always has complex roots every time. So if you have x squared minus 64, it will factor. If you have x squared plus 64, it will not factor, and the roots will be imaginary every time. Okay? So h is pretty easy. I is pretty easy. Can we factor j? So 4x minus 7, 4x plus 7. And I altered number k to say minus 48x. Sorry, go ahead. Well, I looked at the square root of 16x squared. Yeah, just square root the first and the second term. And whatever that square root is goes in the parentheses. So can we do that with letter k? 3 is not a perfect square, and I changed it. It's not 54 anymore. It's 48. Is 48 a perfect square? Almost. 49 is, but 48 is not. So what do? Pull out a 3. So once I pull out that 3, now I do have a difference of squares. So my answer is 3 times x minus 4 times x plus 4. Did I pull out an... Oh, you're right. I need to pull out an x, too. Thank you. Letter L. Can I pull anything out of L? No. There's nothing in common. So if I square root the first one, I get 2a. And if I square root the second one, I get 5b. Oops. So 2a minus 5b and 2a plus 5b. On the next 6, we're going to go one step further and find the roots. So this factors into x minus 5 times x plus 5. What are the roots there? Positive 5 and negative 5. But I'm lazy. So I'm just going to write plus and minus 5. And that takes care of both answers. So on n, is n a difference of squares? 6 and 6. So plus or minus, equals plus or minus 6. What about letter O? It's backwards, though. Doesn't matter. That has no effect. So the factors are x plus 10 and x minus 10, which means my roots are plus and minus 10. So in letter P, is this a difference of squares? Yes. So 2x minus 5 and 2x plus 5. What do I do from here? Set them both equal to 0. I want to know what number makes each side equal 0. So I'm going to add 5 and then divide by 2, so x is 5 halves. And the other one, I'm going to subtract 5 and divide 2, so it's plus or minus 5 halves. And now if you plug that back in, you'll see that it is 0. 2 times 5 halves is 5. And 5 minus 5 is 0. Sorry, let me back up. Let's use a different color. So 2x plus 5 and 2x minus 5. You get that? So now I put equals 0. So I just subtract 5. 2x equals negative 5 and divide 2. X is negative 5 halves. And once you've done it once, you can just do it in your head. On this side, I'm going to add the 5 and divide the 2. So I get 5 over 2, which turns this into plus or minus 5 halves. Letter Q. What should we do there? We could check to see if 196 is square rootable. It is. Or we could pull out the 4. So if I pull out a 4, then I'm left with x squared minus 49. So 4 times, what are my factors? Does it matter which plus, if I write the plus first or the minus first? No. So what bearing does this 4 have on my answer? No, it doesn't affect it at all, because it doesn't have an x. It's just a constant, and that constant does not change the answer. So my answers are plus or minus 7. Well, what if I square rooted both of them and I found out that 196 is actually 14 squared? Then I would have got 2x minus 14 and 2x plus 14. I still get 7 in both cases, because I would add the 14 over and divide by 2, subtract the 14, divide by 2, which gives me the same plus or minus 7. All right, letter R. Is R a difference of squares? Not yet, but I can pull out a 2x, which would leave me with 9x squared minus 4. So my factors would be 2x and what? 3x minus 2. 3x plus 2. Chaseley, what are the roots? Well, if I set this equal to 0, I get negative 2 over 3. And the other one is going to be, hang on, we'll get there. Now, this just gets set equal to 0. Well, 2 times what equals 0? 0. So whenever you have a lone x, it's like saying x minus 0, which is just 0. Good job, Chaseley. Do a dance. Okay. Go ahead and work on this assignment. You should have it done by the end of class.